Okay, so this is chapter 4, day 1. The first question asks you to compare and contrast histograms, stem and leaf displays, and dot plots. Okay, most of you who put down answers talked about the way they look, okay, which is fine. That's how they're different, right? Dot plots have dots, and histograms are in bars, and some leaf plots are numbers of the line, right? A lot of you talked about how it looks. That's fine, okay? But there are two examples where students kind of went beyond that and we'll talk more about when that would be useful, or kind of a deeper look at how they're different. Okay, they're both used to display. So stem and leaf plots and dot plots are used to display small amounts of data. Okay, in general, that's very true. Okay, if you have a small amount of data to display, stem plots and dot plots are pretty useful. Okay, if you have a large set of data, usually use a histogram because it's more summarized, right? You have just bars instead of individual data points. Okay, they both show basic facts about the distribution. We'll talk a lot about distribution today. They are similar to histograms, but they showcase individual values instead of having all the data combined. Okay, now that's, in my mind, now I'd have this in your notes, this idea that okay, now this is a plus and a minus. Okay, in a stem and leaf plot, and for the most part, for dot plots, you still have the individual data values, right? So if you need to be very accurate, you still have the data values there in the display. Okay, histograms are summarized, and so you can't get back to the data. You've lost some information there, and so it's better to summarize a lot of data using a histogram. Anyway, does that make sense? The small data sets, stem and leaf plots and dot plots are nice because they keep all the data there. Histograms generalize a lot better. Histograms show the clusters of values that are quantitative and look at the group as a whole. I would say that all three of them do that. Stem and leaf plots and data plots show more information than histograms. That's true. So this is very, very well analyzed. Compare and contrast. Here's a different one. Again, the student kind of picked apart and kind of looked more deeper than just how it looks. They all display the distribution of the data. That's true. Histograms use bars. There's multiple values. Stem and leaf display shows data by using numbers. I think this part that I picked this out for was, which I've already talked about, the fact that dot plots use dots instead of bars, and leaf to display the values. They're best used for small data sets. I thought that was really good. These only show the basic facts of distribution. Okay, so very good on those answers. Any questions on histograms, stem and leaf plots, or dot plots? Okay. The next question was 3 characteristics to describe distribution: shape, symmetry, and strangeness. I just made that up, by the way. All the S's. I thought that was kind of cool. Is that cool?
I was confused. Like, I don't know.
Was that confused? Because it was like shape.
I was really tired, so I was like, I was going to think that it was part of the reading. So.
Okay. It was like modes, right? Modes and skewness and unusual effect, right?
Mm-hmm.
Do you like that all being the same layer? Like shape, symmetry, and strangeness? Is that?
Sure.
Is that just strange? You can say it's strange. I won't be offended. It's strange. Okay, never mind.
It's okay.
Okay, fine. I thought it would be really cool, but I guess not. Am I still recording? Okay, so we'll call it modes, symmetry, and outliers. Yeah. Okay. So many of you had this answer. I'm not sure I picked this one in particular, but many of you talked about other things that would be important are the measure of the center and the measure of the spread. So that was pretty good. Okay. other facts be useful in describing a distribution. You know, it can be symmetric and unimodal, but you know, how tight or how varied is it may change. So that was really good. A lot of you had this idea as well. Okay, what did you find confusing or interesting about the reading? We'll talk about these as we go along. The first section on histograms, I was a bit confused about the bins, and we'll talk about the bins. I don't completely understand the concept of, or even the points of using data plots. So, data plots are used for small or large data sets. Usually for small. Okay? And I think the reason why dot plots are used is because they're so easy to draw. Meaning, for a stem and leaf plot, do the values have to go in order? Yes. For a histogram, do the values have to go in order? Yes. Okay. For a dot plot, you just draw the line and go down your data and start putting in dots. Okay? It's a very quick way to get a distribution. Okay, so I think dot plots are used as a very quick way of looking at your distribution. Okay, so you can quickly just draw a line, have some dots, and see is it unimodal, is it bimodal, is it symmetric, is it skewed? You can see those things just from a dot plot. But I've never seen, published research that has a dot plot, and they're all histograms. Okay, so as you're, giving it a final touch, you probably use a histogram more than you would use a dot plot. Okay. And we'll talk. I've skipped over this fact, and it's not a good thing that I've done that. We'll talk more about quartiles today. Okay, so we'll come back to these ideas. Okay, chapter 4, day 1. Are you ready? You don't care. You're all like, whatever. Okay, now. Number of siblings or number of countries visited. How many of you find this is an interesting topic? Number of siblings.
Oh,
You can go twice. 1, 2, 3, 4, 5, 6. How do you find number of countries visited is interesting? Whoa. Everyone but Coy. It's okay. You're looking down. Okay. So. Okay, in this room. How many have visited 0 countries? I'm just kidding. Okay, 1 country. You've lived in Japan your entire life. You've never left the country. 0. 2. You've been to only 2 countries. For example, the U.S. and Japan only. You've never gone anywhere else. 2 countries at all. I mean, it could be Philippines and Japan or whatever. Japan has to be one of them because you're here
right now.
So that's one of them. 2. No, you visited. Visited.
The word's right there.
Okay, so there's been 2. Okay, 3 countries. You've visited 3 countries. 1, 2, 3, 4. I have 2, so I'm fine. 4 countries. You're an outlier. What? That's not fair. Okay. Koi? Okay, Koi 4. Oh, Melissa? No. Okay, sorry. 1. 5. Who's left? What? Okay, how many? 6 countries. 26. Are you proud of that fact? Okay, good. Okay, and? Okay, is that everyone? So it's 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Does it count if you're like still inside mom
What do you think? I would say it doesn't count.
Okay.
You can't visit a place in utero.
Wait, what if you have like a layover in another country, but you only stayed there for like 10 minutes?
Did you visit there?
Okay.
Did you go through?
What? You're 20? Okay.
2 outliers. Okay.
Have you lived in Europe?
Yes.
Have you lived in Europe?
Yeah.
How many have lived in Europe? What? Maybe you have?
15.
15.
So we go, we were just, we went and we go, no, she was in. Oh.
Okay, anyway, so. Okay, so no one has 0, 2 people have 2, 5 people have 3. There's a frequency table kind of down here because it's a little weird, but
7, 8, 9, 10, 11, 12, 13. That's 13.
Yeah.
Oh yeah, this might just have switch.
no.
Oh, you
Can I be here too? No, I'm not cool enough anymore. It's okay if I'm in the data too? Okay. All right. In your notes, will you draw a stem and leaf plot of this data? Can I stop you before you finish drawing your stem and leaf plot?
I don't know.
Look at your notes. It should be in there. Okay. Now, based on our distribution, it might be helpful to have split stems. I think that's what it's called. I'm not sure if there's a name for it or not. Do you know what I'm saying? Okay. If you do 0, 1, 2, how long will this first one be? Super long, right? Okay. It might be nicer to draw it as 0, 0, 1, 1, 2, 2, where these are the numbers between 0 and 4, and these are numbers between 5 and 9. And that would alleviate some of it, right? So you could split it up and have what?
And then the distribution still kind of be weird because it will be like 1 and 2.
What do you mean?
Like if you did the 1 and 2, like if you did it like that, then the 1 and 2 would be like at least.
Well, then this would be between 10 and 14.
Yeah, so that one would still be empty. So like
That's
the
fine.
distribution still be.
No. Well, that's what the distribution is. We can't change the fact that's the distribution.
So I would like.
I think it'd be easier for us to see the distribution if it's a little more spread out than if it's all bunched together. That's the point. Okay, so here's our distribution. Okay, talk to me about the modes. Okay, so here is an important fact, okay? Back in Algebra 1, they talked about the mode. Okay, what's the mode? The most common number. Okay, now, the idea of the mode as the most common number is not very important when you have large data sets. Okay, so when we talk about modes in this class, we're not looking at the most common number. Okay, we're looking at general trends in the data. Does that make sense? Okay, if we put the most common number, it could be a very uncommon number, but you have a large data set and that number happened to happen a couple of times. Okay, so we're looking for kind of some, what do they call them? They call them like humps, okay, in the data. So these have general trends in the data. Those are modes to us, not a single number. Okay, so is it unimodal? Is it bimodal? Is it multimodal? Is it uniform? It's unimodal. And where's the mode? Okay, this part right here is the mode. You see that? Okay. Yeah. Okay. Is it symmetric? Now, you can be forgiving on this, but can you forgive it that much?
No.
No, because that's totally now. Is it left skewed or right skewed? It is right skewed because the higher numbers is where the tail is. Okay, you always name it based on the tail. The tail are higher numbers down here, and so it's right skewed. It makes more sense when it's
Other way. So you have to
like this. And it's right skewed. Okay. Are there any outliers? Can there be 3 outliers in a data set of 13? What is an outlier? Does the book define outlier yet?
Yes.
What's an outlier according to the book? Hold up. All right, I will hold up. Yes.
It stands away from the body of distribution.
What is it?
It
It stands away from the body of the distribution. Okay, maybe me.
Extreme values that don't appear to belong with the rest of the data.
Okay. So Justin was kind of more of a mathematical one, right? McEwen's was kind of a, it's the nature is different, right? Francesca, have you lived in Europe?
Yes.
Okay, so now there is a mathematical definition of an outlier, and I don't think it's in your reading yet, so we won't define it that way yet. I think it's in chapter 5. There's a mathematical definition of an outlier, but still, it's a gut feeling of the data just seems different. Okay, now I would agree that these 3 data points are a little bit different. Okay, and I think the commonality is these people have lived in Europe. Why is that important? They're so close together, it's easy to visit other countries, right? Okay, whereas I think the rest of these people, now correct me if I'm wrong, but the rest of these people have lived primarily in the States and in Japan, right? Now we have them traveling, right? We've gone to a few other countries, but to travel in Japan, you have to get a plane, right? So you tend to visit fewer countries. Whereas if you lived in Europe, I don't even walk across the border, but okay. So would you agree that the nature of the data is a little different?
Yes.
Okay. So in that sense, I would consider these 3 students outliers because the nature of the data is different. What? Is it wrong to be an outlier? Is it bad to be an outlier? What? What are you laughing at?
I don't know what I'm saying. Someone said you're an outlier.
Okay. Now, outliers have the most interesting stories, by the way.
What's funny? I thought you were going to explain more.
No, you should read the book. Anyway, outliers have the best stories. So you should never just throw out your outliers and say, well, they're different, so we should throw them out of the data, okay? Because they have the most interesting stories, the outliers. Okay, why is it that they're so far past? It's probably because of Europe. Is that partially why? When did you visit most of your countries?
Huh?
When did you visit most of your countries? Was it when you lived in Italy?
Actually, no, that was in the States. My family's so spread out. Like, I have a lot of family from my side.
Okay.
We're in Nebraska, and we go to South Dakota.
Those are states. Countries.
I know, but I mean, like, we visited places in Italy too, but I mean, in comparison.
Countries. How many countries have you visited? Countries.
Oh, well, in that case. If we were doing the
Well,
we get lying.
we'll come back to. Was it mostly in Europe that you visited lots of countries? Okay. Was it Europe, right? Germany, right? Okay. All right. So the nature of the data is differently.
Italy too. Okay, so.
Italy's the one.
Okay. It's okay. It's okay. It's okay. It's okay. It's okay.
Other places. It's just.
Do you get the effect that they're different, right? Okay. Are there any gaps in the data? Okay. Now, be forgiving about gaps. Okay. If you're missing just like one cell, just a couple numbers, and based on the bin widths, they could be off by a little bit. Okay. In this case, the jump between 6 and 15 is that significant based on our data?
Yes.
Yeah. I would say there's a gap right here. Okay. And that gap is the difference between those who live primarily in the U.S. and Japan and those who have lived also in Europe. Justin.
Wait, so if you have like a smaller set of data, do you have to be like more strict, or can you just stay the same for all of them?
if you have a smaller set of it depends. It's a horrible answer, I know. I think I'm a little more forgiving on larger sets of data. I don't know. Like, to me, the difference between 6 and 15 is a pretty big jump. If we survey the entire school, you'll get students who went to 10 or 9 or 8 countries, right? But I'm pretty sure that the distribution would look something like ours did, right? There's a huge mound, and it kind of will dwindle off, and then be like, I don't know if it'll go back up even. It would be like that. I don't know. I wonder if there'll be a second mode because of Europe. There may be. I don't know. I'm curious. But there may be a spot, in here that we might, maybe 0. I don't know. Look at the entire school to know that. But in general, don't be too strict. Okay? When you're working with real data, you have to be kind of forgiving. So I think in general, I'm forgiving on everything. Just kind of forgiving kind of again. That's just who I am. All right. Okay, shoe sizes. Shoe sizes. Now, since I knew there would be more females in the class than males, okay, if you are male, take your shoe size and subtract 1.5. We'll do sizes in women's sizes since most of you are female. Okay. Now, I know you may use different sizes based on different things, like your athletic shoes and your, street shoes and other stuff would be different. But in general, what's the first shoe size you look at? Okay, I'm curious. If you're the male students, subtract 1.5 from your shoe size. Okay. So who has the smallest feet? Okay. I understand the different shoes are different sizes. Where's the first size you look at? So look at 6.5 first. Okay. Who's smaller than 6.5? Who else has 6.5? Okay. Who wears size 7? Who wears size 7.5? Size 8. Okay. Size 8.5. Whether that's men's 10. Size 9. Or men's 10.5. No? Okay. 10. So, woo, not 10. 9.5. That's 11. Size 10. 11.5.
What is the number on the 10? 9.5.
9.5 is 3. Oh, did I miss you? Sorry. Okay, now get everyone. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What did I miss?
So there was someone smaller.
It's okay, it's okay. It's okay. All right. Now, I think looking at how spread out this data is, right, based on points, I think that a stem and leaf plot wouldn't be very helpful to us. Does that make sense, right? Okay. And a dot plot would look like this on its side. Does that make sense?
Yes.
Okay, so let's construct a histogram by hand. They're already ordered. Okay? And the question about bin widths, I can't remember who it was about bin widths. Let's start off, so here's our histogram. Okay, here's our histogram. Okay, so I will start off with 5. Now, how wide do you want the bin to be? And you think that as like in bins, you push the data in bins, and they kind of fill up in the bins, and they kind of create this distribution. How wide do you want it to be? Like, it could be like width of 2, a width of 1, a width of 3.
One? Is it like the intervals?
Yeah, so the intervals.
Oh.
I'd probably go with 2. It's probably a pretty good width here. Okay, so we're looking at 5 to 7. You got kind of go sideways. I don't know. 5 to 7. We'll go. Now, with the work with the endpoints. Is 7 in the next one or the first one? Is it 5 to 7 and 7.5 to 9, or is it 5 to 6.5, 7 to 8.5? But where does 7 go? Does 7 go up or down? We have to decide. It doesn't matter. We have to decide though.
Up.
Does 7 go up or down?
Up.
7 goes up. Okay. It doesn't really matter as long as it's consistent. So this is 5 to 6.5. Make it smaller. Okay. And then we'll have 7 to 8.5. Okay. Then we have 9 to 10.5. And we have 11 to 11. Okay, so how many do we have between 5 and 6.5? We have 4. So 1, 2, 3, 4. How many between 7 and 8.5? Oh, you know what? This is going to show what I want. Okay, we're backing up. Well, let's keep going. Then we'll come back and redo it. Okay, how many between 7 and 8.5? 4. Between 9 and 10.5? 5. Okay, how would you describe this distribution? Uniform. Is it symmetric? Be forgiving.
Yes.
Is it symmetric? Yes. Okay. In general, be a little forgiving. Okay. Are there any outliers? Are there any gaps? No. Looking at the fact we're missing one here is not significant. We're missing things here is not significant. Okay. That's not, in my mind, big enough of a gap to be a gap. Like before, we had a gap of like 10 countries. That was a gap. Okay, now, this wasn't showing what I wanted to show. Okay, which can show you that if you're too general, well, the data will look different if you have different bin widths. So do you all have this in your mind? Tell you what, let's just remember it like this. Let's go on the page. Bam. Okay. Okay, let's have a bin width now of 1. So let's go from 5.5 to 6. Is that okay? 6.5 to 7. 7.5 to 8. 8.5 to 9. And then we have, right here, we have 9.5 to 10. 10.5 to 11. Okay. How many are in the 5.5 to 6? 1. How many are in the 6.5 to 7? 4. 1, 2, 3, 4. How many are 7.5 to 8? How many are 8.5 to 9? How many are in this 9.5 to 10? 4. 10.5 to 11. Okay. Now looking at the same data, just displayed differently. Is this data, is it unimodal, bimodal, or multimodal, or uniform? It's bimodal. Okay. Now, do you have a problem with that? That now it's bimodal. Before you said it was uniform, and now it's bimodal. What does that mean? That was really good. Say it louder.
The way you
Choose.
choose your bins affects how the graph will display the data.
Yeah. So your bin width could make a difference on how your data will look. Okay. So if you only have like 3 bins, which is our problem here, it'll be over summarized. Okay. You could have 1 bin, right? There's no information there for you. Okay. Here we have more bins, and so it's a little more detailed. And everything is shorter here. Do you see it's all shorter? Okay. So just be aware now. There isn't really a set rule of thumb of how many bins to have or how wide they should be. But if you try it and it looks over summarized, then just try a different bin width. Overall, it's too low. Try a larger bin width. Okay. Now, why is it bimodal? Okay, there are 2 lumps. Let's talk about the data. So why in this group are our shoe sizes as bimodal? So in general, who's this? The guys. In general, who's this? Girls. So why is it bimodal? Different genders, right? Okay, so looking at data is a lot more than just looking at the picture. Okay, it's telling the story behind the picture. Okay, and thinking of why could this be, or who are these 2 different clusters, or why is this group showing up to be larger than that group? Okay, seeing those patterns is what this class is all about. Okay, so it's bimodal. Is it symmetric? If we're being forgiving, yeah, it's roughly symmetric. Okay. Now, if you go back to the data and look at the data a little more closely, it may be a little more right skewed, because there are more girls in the class than men. So there's more data here than on this side. Okay, but I would be okay with it saying it's symmetric. Okay. Are there any outliers? No. Are there any gaps? No. Okay. Are you okay with size 6 shoe not being a gap? Even though there's a space, doesn't mean there's a gap. Okay with that? Okay, now if someone had size, 3 shoes, I would say that there's a gap. Okay, or size, 13s in women's would be a gap. Okay? And there's a gap in an outlier to figure out why. If there was a toddler in the room, they measured their shoe size, that'd be a gap, right? They're an outlier for a reason. They're a child, or a clown. I think it's clown talking about your book. No, it's a different chapter. Talk about a clown's shoe size and that being way an outlier on the upper end. Good. Okay, so here are the raw test scores from our last test. I've used the AP rubric and kind of scaled it so it's a percentage instead of the raw test scores. Okay. Let's see here. I want to. Verification.
Oh yeah.
There we go.
Probably.
Okay, so I want to show you how to do a distribution on your calculator. Okay. So if you have your own calculator, or if you have TID tracing right there, go ahead and open it up. Okay. Now, in this class, you will use a lot of lists. Okay. So second stat. No, just kidding. Don't do that. Hit stat. Underneath the delete button is a button that says stat. Okay. In this class, that'll become your favorite button on this entire calculator. Okay. You will love the stat button. Okay. So push the stat button. Okay. And you want to edit a list. So push enter to edit the list. Okay. Now please listen very carefully. Is there data in your lists?
No.
How many have data in your list? It's okay if you do. Okay. If there's data in your list, go to toggle over and highlight the list and push clear.
Not delete.
Not delete. Push clear.
Deletes the list.
Yeah, we'll delete the list. You can like restore the defaults to get the list back, or
Did that
some way of
last night,
restoring
I was
it.
like,
Yeah. If that happens at home, bring it to me. I can probably figure out how to fix it, but it takes some time.
I
Okay.
just turned it off and then turned it back on.
That's it?
Yeah.
Oh wow. I think I have to restore the defaults. Clear the whole calculator. Anyway, so clear it out. Clear. Okay. Will you, in the list 1, will you type in these scores? Okay, so you have your data in. So the next thing you will do is, you see above y equals, it says stat plot. Okay? Anything with the word stat on it on this computer, you will like and you will use. Okay, so hit second y equals. And we can put it in plot 1. Why not? Enter for plot 1. Make sure the plot is on. Okay, now, of the type, which of those look like the one you're looking for?
The third one.
The third one looks like a little histogram, right? Okay. Now down it says X list. That's the list you put the data in. Which list do you want?
First one.
First ones. Okay. So highlight over X list where it says L1 or L2. Is it L1 for you?
Yeah. Yeah.
Okay, mine is L2 right now. If I want to change it, you hit second one. See above the one, it's L1 in blue. See that? Okay. So list 1, frequency 1 is fine. When you're done, well, you could hit graph. I don't. Okay. Hit zoom. Crush zoom instead. Zoom. You go down, and there's zoom 9 is zoom stat. Okay. Anything with stat is your friend in this class. Okay. So instead of hitting graph, I always hit zoom 9. So zoom the number 9 is sufficient. So zoom 9. Okay, type your data in, turn your stat plot on. Okay, zoom the number 9, and it will give you a distribution. Yeah. Yes, you can. Okay, you all see the raw scores? Yes, you do. Okay. Now, is this data, is it unimodal, bimodal, multimodal, or uniform?
Oh.
Uniform.
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 How many say it's unimodal? How many say it's uniform? I think you heard me.
Because uniform and unimodal, I just heard you, so I wasn't reading it yet. Then
Oh, okay. How did none of these it's unimodal? Why not?
it's all like pretty level.
It's pretty level. Okay. Who do you think it's you think most of you think it's uniform? Okay. I'm curious. I just had my name. Now, I mean, if you think it's uniform, I think you have a point. I think it's a little more unimodal because I think there is, in general, I think it would be kind of a heat in the middle, like a up in the middle. Anyway, trying to look at it like this idea before about having bin widths. Okay, will you go, just so you know how to do this, will you go to Window? The window button. You see the window button? Push the window button. Okay, so it'll have the X min and X max. That's the min and the max. Okay. Our lowest grade is in the 50, so again, 50 is your min. 50 as the min. I put 100 as the max. Then what bin width do you want? Try 5, just for fun. So sorry, not bin width. It says X scale. Change the X scale to 5. Okay, and then hit graph. You can change the Y scale to the Y min be 0, the Y max be 7. What? Well, even though it goes down a little bit, doesn't necessarily mean it's buying a little. You're looking for general trends in the data, not just, you know, like a bar being lower than the others. Okay? Do you still say it's uniform? You think it's more unimodal now? If you want, you can change the bin width to be 4 or 6 or 7 or 8. And have look at this different bin width and kind of see if you still think. If you still think it's uniform, I'm not going to fight you on that. I mean, there's a point there that it's kind of uniform. It's kind of right in between uniform and unimodal. I'd probably take both as the correct answer if this was on a test or quiz or something.
I made it 5 later.
That bin width is too small.
Mine's 3.
Okay. Okay, so is it symmetric? If you're all looking at different bin widths, maybe a little different in your opinions, but would you say it's roughly symmetric?
Yes.
I'd probably say it's roughly symmetric. Okay. Well, is it strongly skewed? No, it's symmetric.
Oh.
It's not strongly skewed. Maybe slightly skewed to the right, but it's pretty close to being symmetric. Okay, be forgiving. If you're in error being a little more forgiving. I'm not sure which way forgiving is with the modes, though. I don't know. Are there any outliers?
Yes.
Okay. Now there is a gap, right? I mean, there's not a gap. I probably should use that word because we've already defined it to be something. But this value is higher than the other, right? Okay, but do you think there's something that's different about that test than about the others? I mean, like something's different about that student than the others.
Everyone else.
Is it something different in the nature? Okay, we need to step back. I would say that this is not an outlier, personally speaking. Okay, if I took the test too, that would be an outlier, right? Because it'd be different about me than about you. I've learned this all stuff before. You're learning it for the very first time. Okay, or if we had someone who's in Algebra 1 take the test as well, and then get like a 30 or a 20 or probably like a 10. That'd be an outlier, right? There's something different about that than about the others. Okay? So in my opinion, this is not an outlier, even though it is higher than the others. There's nothing different about that student than about other students. So anyway, if you called an outlier, I probably wouldn't count it wrong because it's okay to have different opinions than me on these things. Okay? By the way, where would you say the center of the data is? Should we find it?
Right there.
Right there. What?
This book right here.
Okay. So anyway, we're going to switch gears in the lesson a little bit. We've talked about. Let's summarize this before we move on. Okay. Describing distribution.
It's for describing.
Okay. Is that better? Okay, good. Okay, so describing distributions. There are 3 things you're looking for. I've asked these questions over and over again today. Okay, what's the first question? Shape. But more specifically, how many modes there are. Okay, because I think shape might be confusing with symmetry. What's the next one?
Symmetry.
Hey, good job. Okay, what's that one? Is it strangeness? I made that up. Outliers or gaps in the data. Okay? Now, what? If you want to use the word strangeness, you can. Okay, now you cement these in your brain. Okay? If ever on a question I ask you to describe the distribution, I'm looking for these 3 things. If you forget to talk about one of them, you won't get full credit. Okay? When I say describe the distribution, I'm looking for these 3 things. Make sure you talk about how many modes there are. Is it unimodal? Is it bimodal? Is it uniform? Okay? You may want to describe it as well. Okay? Because if you back with the raw test scores, if you said it was uniform, I'd probably give it to you. If you said it was unimodal, I'd probably give it to you. If you said it was multimodal, I'd probably mark it wrong. Okay? Talk about symmetry, talk about if it's symmetry or skewness, outliers, gaps. Okay, these 3 things I'm looking for. Does that make sense? Okay, let's switch gears and talk about measuring center and spread. Okay? How can you measure the center?
Median.
The median. What's the median?
Middle.
The middle. Okay? And how else can you measure the center? The mean. Which is what? The average. Okay? Now let's go back here to this set of data since it's in your calculator already. Will you add these up and divide by 14 probably? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? Now just for the sake of speed, will you type in second stat, see ops? See ops?
Yes. Where?
Second stat or list. Ops. If you go down, oh, math. Go to math. Sorry, not ops. Go to math.
Then it's a me.
Yeah, you can find the mean, I guess. That's fine. I was looking at the sum and divide by 12. Who cares? So push step math 3 or mean. Second one, list 1. Close parenthesis, enter. Doesn't work on mine because I don't have data in there.
71.9.
What'd you get?
71.9.
Okay, the mean, 71.19. Okay. Now, by the way, when I was talking about the fact that this class has done better than my previous years, my previous 2 years teaching this class, even giving very, very similar tests, had the mean raw score about 63 and 65. And this class got a 71, which makes me really excited. Okay?
72.5.
Okay? Now, go back to find. Now, what is the median? It's the middle number. So how would you find the median by hand?
You would graph the number of how many there are, plus it by 1 divided by 2.
No. Well, that would give you which term you want to find. Okay? Now, they have to be put in order first. Right? Should we do this by hand so you can see it?
Median.
The median by hand.
Did you just put it in order and then?
You put it in order,
You
cross things out, right? And you get the middle number.
Yeah. If you get 2, then you just
Take the average.
Yeah.
You okay with that idea?
Yeah.
Okay. If you're going to do it by hand, I guess you get the calculator. You're not going to use the sort anyway. Okay. So what's the median?
72.5.
Okay. Now, are these similar? Are they close together?
Yes.
Yes. Okay? I don't know why I wrote that down. Is that better?
Smiley face.
They're similar, right?
Yes.
Okay, let's go back here to this one. Okay, will you take our... Wah! I'm okay. I'm okay, I promise. Okay, will you take our countries visited? Okay, countries visited. Will you find the mean and the median of this data? Okay, so put it in list 2 instead, and then find the mean and median of list 2 if you can. Okay, you must put in 3 5s and 2 2s.
There's no
Okay.
way.
What? There's no 1. Okay, what is the mean of this data? Oh, well, that's fine. 7.3 is good enough. Okay, what's the median? Are those similar? No. What is different about this data and the other data?
The median or farther apart than the other one?
But why are they farther apart?
Because there's gap.
Because the distribution.
The gap makes a difference.
The distribution isn't as even.
What do you mean even?
It's not spread out. Like
The other one was more
So the-
uniform.
The other one was more uniform.
this one's skewed.
This one is skewed. Now, okay, let's kind of take a hypothetical situation. Hypothetical. Okay? Well, no, I mean, I don't have enough pictures, and I need to kind of wrap this up in the next 15 minutes. So, if I had this as my distribution, okay, where do you think the mean would be? Where the balancing point would be?
Between the largest.
This would probably be the mean. Okay. Where do you think the median would be? Where's the middle number?
Towards that little vowel too.
To the left.
To the left of the mean, right here?
Yeah.
Like right there? Would they be close together?
Yes.
Okay. Now, the mean is the middle number. The mean is the average. Okay, so if I took this value and put it up here as an outlier, would that change the median?
Yes. No.
Oh, no.
No. Oh wait, no.
Would it change the median?
No.
Has the middle number moved? No. Okay. Would it change the mean?
Yes.
Yes. Would it go up or down?
Up.
It would go up. I'm not sure how far up it'll go, but it'd be up, right? Okay, so in this situation, there's a far outlier, or if it's skewed, would you think that the mean or the median would be a better indicator of where the middle is? Or a better indicator of what's most common? The median would be. Okay? So if you have far outliers, or it's strongly skewed, then the median is a better indicator of the center than the mean. Is that in your notes?
Yeah. There's no.
Okay, if it's not in your notes, write in your notes. That's a really important idea. So we usually use the median for skewed or like major outliers, far outliers. There we go. Far outliers. Okay. Now, should we just always use the median?
No.
Why not?
Because sometimes the mean presents better. I understand.
Because the book said so.
Oh, like, what if
Okay.
Actually, wait.
Okay. Now, because the mean takes into account every single data value. It's a more specific measure of the center. Okay. The other problem that we could run into, well, never mind, that would be the same thing. Anyway, the other problem we could run into is the fact that, anyway, it's a better measure of the center when it's symmetric because it uses every single data point. You add them all up, divide by the number of data points you have. So if it's symmetric, we use the mean. Does that idea make sense? Okay, so let's go back here. Why do you think that the median, I just gave the answer away. Is this symmetric or skewed? Skewed. Do you want to use the mean or the median? Median. Now, would you say that in our class, the average number of countries visited were about 3? Is that a pretty common answer? If you said it was 7.3, that seems a little off. Who has been to 7 countries in our class? Nobody. So you say that in our class, the average student has gone to seven countries. Is that true or false?
False.
It's false. Okay. Now back to yes. So this data that I don't have drawn here, why were the numbers so close together? More than unimodal.
That was really big.
Okay, there's no gaps, right? And there was no skewness, right? So it was symmetric. For data symmetric, then we can use the mean instead of the median, or we can use, they're both pretty close together. Does that make sense? Do you get that measure of the center? Okay. There's one more idea to cover. This section was big. Yes, it was. What?
There's still 9 pages left
And what?
in the chapter.
Oh, yeah. Well, there's a little more we're going to cover. But this has the bulk of the ideas. Okay? The last idea is measuring spread.
Yay!
I don't know. Okay, so measuring spread. How can we measure spread? Okay, the IQR, or the interquartile range. The range. Oh, mom, the range. All right, and what? Standard deviation. Okay, and we'll talk tomorrow, to our next class, much more about this, because it just kind of mentioned it, right? Yeah, we'll talk a lot more about standard deviation next class. That'll be like our main focus. Next class is what the standard deviation is. Okay, what that even means. Let's at least talk about the 5-number summary and how you find the range in the IQR. Let's go back to this data set. It's a little smaller. I guess it's the same number, same size, huh? Okay, let's use this data set. Now, the question was asked about quartiles. Should we find it? Okay, these are in order, right? The median was 3. So here, hold on. There's 13, right? There's 13 of us. So the middle person is 7. So this one is the middle one. Right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this person, we can find out which 3 person it was. Probably me, because I had 3. So I'll be the median. If you're a 3, you can say that you're the median. Okay, so that's the median. Okay, you could think of it as Q2, but we'll call it the median instead. Okay, now Q1 is the median of the bottom half of the data. I've used this one, so I'll talk about these right here. What's the middle of these numbers? There's 6, so I take the middle 2 numbers, these middle 2 numbers, and I average them. Okay, here's the most difficult question of the day. Ready? What's the average of 3 and 3? You guys are smart. Listen, it's an AP class. That's probably why you're all smart. Okay. Now, the next one, 4 or 5. Now, 6 and 15. What's the average of 6 and 15?
5.5.
10.5.
Wait.
10.5.
10.5.
I thought we were doing 65.5.
10.5. Okay. So 3 would be Q1. Does that make sense? Okay. 10.5 is Q3. Because it kind of breaks it into quarters, right? So the first quarter, and the middle, and the third quarter. It breaks them into quarters. You see the quarters? This quarter, that quarter. Okay. So the IQR, like running out of space. Okay. The IQR is equal to Q3 minus Q1. It's the distance between Q1 and Q3. Okay, so what's Q3? 10.5. If I subtract Q1, which is 3, I have what? 7.5. So our IQR is 7.5. You're all like mentally gone, huh? I look at it, you're all just like, are we done yet? All right. Anyway, so the IQR is 7.5. What's the range? It's the max minus the min.
24.
It's 26 subtract 2 and you get 24. That's the range. There are ways of measuring how much variability there is. You're all just done anyway. Man, okay. Okay, I know there's a lot of new information, okay? These ideas are super important, okay? Being able to see distribution and describe it, talking about how to measure the center of the data, how to measure the spread. We'll kind of talk more about these ideas next class. Okay?